Welcome to lesson 8.4, last lesson of the book. Okay, we are going to talk about volumes of solids of revolution this time. Once again, we're going to spend a lot of time trying to visualize this. So the idea behind this one is you take a shape and then you're going to revolve it all the way around to see what kind of shape it makes by rotating it. So, for example, let's just start into example number 1. I have this shape right here. And what I want to do is take this shape and rotate it all the way around. So you can kind of start to visualize that it makes this funnel shape. Help you visualize it a little more, go back to our favorite website. Here's that shape right here. If I rotate it all the way around, I get this funnel thing. You can kind of watch the yellow piece to see the shape that it makes. So that's what we're doing when we take this shape here, and you can see there's my yellow piece, but I take that yellow piece to rotate it all the way around and it gives me this circle. So most of what we're dealing with here are circles because we're rotating things. And that's why when we come back to our notes, you'll notice area of a circle, pi r squared. Because of that rotation that's happening in here, that creates a circle, where r is this section right here, top minus bottom. So what we've been doing all along, that is your r. The top minus the bottom gives you the radius of your circle. So let's set up an integral for this first one. We have this volume. Looks like our limits are from 0 to 1. And we want to do pi r squared. Pi r squared. Because that's how we're getting these circles. And our r is this equation right here, x squared minus the axis, which is just 0. So this integral, or the volume of this funnel kind of thing, is going to be x squared squared dx. And we don't have to calculate it because it just says set up. But that, solving that integral, would give you the volume of this object. Let's try a second one. We're still going to do with y equals x squared, but now we want to talk about it in terms of the y-axis. So now my r is going to go this way, and when I rotate it, my circles are going to go like this. So to kind of visualize this one, if it will come up, might not want to. There we go. Here's our equation, except now we're going this way. So we've got this sort of thing going on, and you can see that yellow one, kind of like, I don't know, a vase, but solid. Anyway, so that's the shape that we've got going on here. Now, because this one is perpendicular to the y-axis, our limits need to be in terms of y this time. So that's going to be from 0 up to 4. And we know it's up to 4 because that's what the problem says so. Now, I'm still going to get pi r squared. But r this time is going to be the right minus the left. And because this is perpendicular to the y-axis, I've got to take my equation and solve for x. So x is the square root of y. So this graph right here is the graph of square root of y. Now, we know it's usually plus or minus, but I don't need the minus one this time because when I do the rotation, that takes care of the minus one on its own. So I really just need this square root of y. And that right there is going to be my r, because right minus left is just 0. So I'm going to get pi from 0 to 4 of square root of y squared. It's just going to be from 0 to 4 of y. And you could take the time to go through and solve this one because it actually says find integral of y is y squared over 2 from 0 to 4. This one's not too bad, which you should end up getting 8 pi. So that is what we called discs, because as you can see when we go through this, that yellow shape, that yellow circle kind of makes a disc. In the next videos, we're going to go through and talk about washers and what a washer is and the formula for those.